Alright, in this video here we're going to be talking about the double angle formulas for sine, cosine, and tangent. So these formulas they can be used like if I know the sine of an angle and the cosine of an angle. If I want to find the sine or cosine of double that angle, I can use these formulas to do that. More often, these formulas are used for simplifying trig expressions or solving trigonometric equations. They're used in calculus sometimes to simplify expressions when you're doing calculus problems called integrals. Sometimes you have to use these formulas to simplify what you have and put it in a form where you're actually able to proceed with the rules of calculus to do the problem. So these formulas, they don't come up every day when you're doing math, but they will pop up every once in a while. So they are important to be aware of what these formulas are and to be able to know how they work and how to use them. Right? So sine of 2x is equal to 2 times sine of x cosine of x. Right? So if I have something that's in this form, sine of 2x, I can convert it to something that looks like this. I can go the other way as well. If I have something that looks like 2 times sine of x cosine of x, I can rewrite that as sine of 2x. Right? Cosine of 2x equals cosine squared of x minus sine squared of x. It also equals 1 minus 2 sine squared of x. It also equals 2 cosine squared of x minus 1. Right? So there's 3 different things we can use for cosine 2x. And when we're using that in problems, generally we just use whichever one is more convenient. Like if I know sine of x and I want to know cosine 2x, well, I'll just use this formula because this is the one that has the sine of x in it. If I know cosine x and I want to know cosine 2x, I'll use this formula because that's the one that has just cosine x in it. Right, if I know sine and cosine, then I can use any one of those formulas and plug the numbers in to figure out cosine of 2x. Right? And these two other forms of this formula down here come from the Pythagorean identity that sine squared plus cosine squared equals 1. Well, if you plug in for cosine, if you solve that identity for cosine squared of x and plug it in, you'll get this. If you solve that identity for sine squared of x and plug that in here, you'll get this one over here. Right, so I'll leave that up to you if you want to double check that. But these two extra formulas for cosine 2x comes from applying the Pythagorean identity to this one up here. All right, and then the last one here, tangent of 2x equals 2 times tangent of x over 1 minus tangent squared of x. All right, so those are what we call the double angle formulas. They're when we know tangent of x or cosine of x or sine of x, and we want to know sine of 2x, cosine 2x, tangent 2x, right? Doubling the angle that we already know. That's why they call these the double angle formulas. All right, I'm going to pause the recording here and erase these and then put up an example where we find sine of 2x, cosine 2x, and that kind of stuff. All right, so the problem here we have is if cosine of x equals negative 2/3 and x is in quadrant 2, find cosine of 2x and sine of 2x. All right, so here they don't tell us what x is, right? They don't tell us what our angle is. They just tell us that the cosine of that angle is negative 2/3, and they also tell us that that angle is going to lie in quadrant 2. Right, so we want to find cosine 2x and sine 2x. So if you recall from what was up here just a minute ago, there are 3 formulas for cosine 2x. Right, now, since we know what cosine x is, I'm going to use the formula for cosine 2x that involves cosine of x, which is cosine of 2x equals 2 cosine squared of x minus 1. Right, now, this cosine squared of x, that might be confusing to some people as far as what that actually means. What that means is it's going to be 2 times cosine of x squared minus 1. Right? Cosine squared of x means the cosine of x squared. We just normally write it this way. We put that squared directly on the cosine just as a shorthand way of writing it. Right? But when you see something like that, like a sine squared or a cosine squared, it actually means the cosine of x, whatever that value is, being squared. Right? So when you understand what that means, well, if I know cosine of x equals negative 2/3, for the cosine of x here, I just plug in negative 2/3. Right, so it's going to be 2 times negative 2/3 squared minus 1. All right, now I just have to do the work to simplify this. So it's 2 times, all right, so negative 2/3 squared. Remember, when I have a fraction squared, I square the numerator and denominator. So negative 2 squared is going to equal 4, and then 3 squared is going to equal 9. All right, so I get 2 times 4/9 minus 1, which is going to be 8/9 minus 1, right? Because think of that as 2 over 1, and I multiply straight across, so it's 2 times 4, 9 times 1. So I get 8/9 minus 1. Now, when I'm subtracting something that involves a fraction, I need a common denominator. So I get 8/9 minus 9/9, right? 1 1 whole is 9/9, and I choose 9/9 because the denominator of this fraction is a 9, so I want to make these two match. And then I subtract my numerators. 8 minus 9 is -1. All right, so cosine of 2x is going to equal -1/9. All right, so that's what I know about cosine of 2x. So, whatever this angle is that's in quadrant 2, the cosine of that angle is -2/3. If I double that angle, that's going to put me probably down in quadrant 3 somewhere, and the cosine of that double angle in quadrant 3 is going to be -1/9. Right, and when we get to the end of this, if I have time at the end of this video, I'll kind of draw a picture of this to kind of give you an idea of what we're actually figuring out here. Because if you don't have like a picture of it, like a mental picture of what you're doing, then it's just abstract formulas and you're plugging in numbers and you don't know why you're actually doing it or what it really represents. So I'll try to do that at the end and draw a picture to show you what's going on. Right, but cosine of 2x equals -1/9. All right, let me pause the recording here so I can erase this stuff, and then we'll do also sine of 2x, so we'll put that up here as well. All right, so now I put up here what we got from that first part. So cosine of 2x equals -1/9, just to save that for later. Now I want to find sine 2x. All right, so sine 2x, the formula for sine 2x is going to be 2 times sine of x times cosine of x. Well, we run into a snag here because I know that cosine of x equals -2/3, but I don't know what sine of x is equal to. So I don't really have a number to plug into the formula there for sine of x. All right, so what I need to do is figure out what is sine of x. Well, if I know what cosine of x is, I can figure out what sine of x is by once again going back to our Pythagorean identity. Sine squared x plus cosine squared x equals 1. All right, so anytime I know sine or cosine of an angle, I can use this formula to figure out the other sine or cosine, whichever one I don't know. Right, so I don't know sine of x, so sine squared of x plus, right, remember cosine squared of x means that this cosine of x, -2/3 squared, equals 1. Right, so I plug in my value for cosine, which is -2/3, I square that, and now I solve this equation for sine of x. Right, so sine squared of x plus, now -2/3 squared, just like we saw a couple minutes ago, equals 4/9. Right, so I get sine squared x plus 4/9 equals 1, and that 1, let me write that right now as 9/9, because what I have to do here is subtract that 4/9 to the other side. Right, so what I end up with then is sine squared of x equals 9/9 minus 4/9, which is going to be 5/9. All right, so sine squared x equals 5/9, but this is sine squared of x, so to figure out what sine of x is, I need to take the square root on both sides of the equation. Right, so I get sine of x is equal to positive and negative square root of 5 over 3. All right, so a couple things there. Just like when we solve quadratic equations, if you watch the videos that I did, doing the algebraic stuff and solving quadratic equations using the square root method, when you do the square root on both sides of the equation, you have to put that positive and negative on the other side, because you can get two different numbers that when you square them equal, in this case, 5/9, right? The negative and the positive of that square root, when you square it, gives you the same result. All right, so that's the first thing. When you do the square root method, and anytime you're doing this, when you're solving for sine or cosine using this formula here, every time you do that, you're going to have to do the square root and make sure you put that plus or minus there. The other thing is, when you do the square root of a fraction, I can't do the square root of 5, but I can do the square root of 9, right? The square root of 9 equals 3. So I do the square root of 9 and just put a 3 in the denominator, and then I have the square root of 5 in the numerator, and notice that square root is only over the 5 now, it's not on the 3 that's down here. Whereas up here, the 5 and the 9 were both underneath the square root. All right, so I get sine of x equals positive or negative square root of 5 over 3. All right, well, if I'm plugging sine x into this equation here, there's two different answers here. There's positive square root of 5 over 3, and there's negative square root of 5 over 3. How do I know which one of those, the positive or the negative, to actually plug into this formula? So if I plug in a different one, if I plug in the positive or the negative, I'm going to get two different answers here for sine of 2x. Well, there's a clue in what they gave us. All right, they tell us x is in quadrant 2. That's the clue that's going to tell us whether to choose the positive or the negative for sine x. All right, think about it like this. If I'm in the second quadrant, right, so my angle is somewhere over here, right? My cosine is negative. Remember, the cosine is the x, and the sine is the y coordinate of this point up here that the angle goes through. Right, well, if it's in quadrant 2, the x is negative, which means cosine is negative. That's why cosine was a -2/3. All right, but if I'm in the second quadrant, is sine going to be positive or negative? Remember, sine is the y-coordinate of this point, and if I'm in the second quadrant, the y-coordinate is going to be positive. Right? If this is, say, quadrant 3 and the angle was down here, the y-coordinate is negative, so I would choose the negative value for sine. Right? So I'm going to say that sine x equals positive square root of 5 over 3, and I choose the positive for sine because we're in quadrant 2. Right? So you have to really pay attention to the details and the information that they give you in order to complete a problem like this. Right? I have to realize that if I'm in quadrant 2, I've got a positive y-coordinate, which means my sine of my angle has to be the positive square root here, not the negative square root. Right? If I was in quadrants 3 or 4, sine would be the negative, and I would choose negative square root of 5 over 3. Right? So important little things to pay attention to that if you miss it, it could screw up your whole problem. Right? In this case, if you didn't notice, like if you forgot to put the plus or minus on the square root of 5, it wouldn't have mattered because we were choosing the positive square root anyway. But if we had to choose a negative square root and you forgot the plus or minus and you forgot to look for whether it should be positive or negative, you just got the wrong answer. All right, so little things to be aware of. All right, so I got that sine of x equals positive square root of 5 over 3 from my Pythagorean identity here, sine squared plus cosine squared equals 1, plugging in the cosine value, and then thinking about which quadrant I'm in. Does sine have to be positive or negative there? So once I do that, I can go back to my formula. So sine of 2x is 2 times sine of x, which is the square root of 5 over 3, which I just wrote the square root of 3 there. All right, so it's the square root of 5 over 3 times cosine x, which is negative 2/3. All right, so when you're doing these problems like find sine 2x and cosine 2x, you're not trying to figure out like what x is. Like you're not trying to figure out what the angle is and then take the sine of that angle. You just use the formulas for sine 2x and cosine 2x and just plug the values for cosine x and sine x into those formulas to get your answers directly that way. All right. So if I multiply all this out, I'm going to have 2 times the square root of 5 times negative 2. So that's going to be negative 4 square root of 5 over 3 times 3, which is 9. Right? So sine of 2x equals negative 4 square root of 5 over 9. All right, so I get that from my formula, just plugging in the values for sine x, cosine x, after I did all that work before to find the value of sine x. All right, I'm going to pause the recording here once more and erase the work that I have up here, and then draw a picture of what these angles look like and what all this information is actually telling us. All right, so I put up here just a kind of a graphical representation of what we just did. All right, so my original angle x, which I don't know what that angle is, but I know that that angle takes me to a terminal point in the second quadrant. Right, so cosine of x was negative 2/3, so the x-coordinate of this point is negative 2/3. And then I figured out that the y-coordinate, the sine of x, would be positive root 5 over 3. Right, that was what I did kind of towards the end of that last example there. So that's the x and y coordinates for the terminal point for the angle x. All right, if I do the angle 2x, which is double this angle, right, that's why they call it the double angle formula, all right, that's going to take me down into the third quadrant. And the terminal point there, well, since cosine of 2x was negative 1/9, the x-coordinate is negative 1/9, and since sine of 2x was negative 4 root 5 over 9, the y-coordinate of this terminal point is negative 4 root 5 over 9, and I know that that point ends up in the third quadrant because both of my x and my y, my sine and my cosine, were negative. Right? The two answers I got were both negative. That tells me my point has to be in that third quadrant. Right? If I had gotten a positive cosine and a negative sine, it means I would have been over here in the fourth quadrant because then I would have a positive x and a negative y. Right? So that's basically what the double angle formula is doing for us. It's telling us, I don't know what this angle x is, but I know it's in the second quadrant, and I know the cosine, the x-coordinate, is negative 2/3. If I double that angle, I can use the double angle formulas to find the x and y coordinates of that point, right? The sine and the cosine of that angle 2x, right? Doubling the angle that we have here, taking us down into the third quadrant, right? So I just wanted to give you a graphical representation of what we just did in that example, just so you have some mental picture of what you're actually doing rather than just remembering formulas and plugging numbers into formulas and not really understanding what it's telling you, right? This is what that stuff was telling us. All right, so that's it for the double angle formulas. And I'm going to do some other videos for like half angle formulas and things like that, so make sure to check out these other videos I'm doing where I talk about these other formulas for the trig functions.